In this video, we are going to cover some of the common mistakes made when installing Rails to the clawFR system. The information that we will provide is applicable to both the 5-degree and 10-degree tilt systems. Let's start by taking a quick look at proper Rail installation. Rails represent the east-west structural component of any subarray. Rail segments are connected together to create continuous structural components of varying lengths. Bolts are used to connect the rail segments together and to fasten them to either module connectors or bases, depending on the array design. There are specific riv nuts or pilot holes on the module connectors and bases designed for rail connection. It is incorrect to connect rails by stacking them continuously from east to west. As you can see here, each rail segment is being placed on top of the preceding rail segment in a cascading fashion. When rails are improperly installed in this way, the rigidity of the structure is reduced, which can lead to system failure at wind loads below the worst-case site loads. Furthermore, installing the rails in this incorrect manner will also result in the rail connector bolt not being able to go through the correct hole. Correct rail placement is achieved by staggering the placement order between the S locations and the L locations that span the north and south running module connectors. Start by installing rail segments at each S location in a subarray. Next, place a rail segment at each L location. The L rail is placed on top of the S rails. When properly stacked, the fastening bolt will go through the hole on top of the L rail, then through the slot on top of the S rail located below, and lastly into the riv nut or pilot hole located on either the module connector or base. It is incorrect to thread the bolt through the slot on the L rail. Tighten the bolts to 6 foot-pounds when installing into a riv nut and 3 foot-pounds when installing into a pilot hole. It is important to ensure that these requirements are met when placing rails. Rails are installed with the open face of the rail facing south in all locations in the array except for the southern perimeter of the array. When installing a rail to these southern edges, the position of the rail must be reversed so that the open face of the rail is facing north, or towards the module. Remember to install rails to all southern facing perimeters on the array. This includes interior corners. Interior corners occur when an array includes module omissions due to roof obstructions, system size, or layout constraints which result in rows with unequal module counts. Additional rails are installed to secure the inside corners created by the omitted module. An inside corner exists at any location where a module does not have another module to the south, but adjacent modules do. For example, this module has no module to the south of it, but its neighboring module does have a module to the south of it. Therefore, a rail must be installed not only to the southern edge of the module, but also to the southern edge of the adjacent module, creating a more secure structural component. Likewise, this module has no module to the south of it, but both of its neighboring modules do. In this case, a rail must be installed on the southern edge of the module and both adjacent modules. Remember that because this module represents a southern edge of the array, the rail needs to be installed with its open face oriented towards the module. We hope these explanations have been helpful. Please visit our website or contact our tech support team if you have further questions.